Let's take a look at the we do problem. This one says, for the first question, how many grams of potassium hydroxide would be dissolved in 250 milliliters of a 0.10 molar solution of potassium hydroxide? So using the formula for molarity, I'm going to go ahead and use purple. So molarity equals, again, moles of solute, that's what you're dissolving, per liter of solution. We know molarity. We know the volume, so we need to figure out really grams of potassium hydroxide by finding out moles first. I'm going to use dimensional analysis for this because molarity is a conversion factor right here. If I start with my volume, but in liters, and try to convert that to moles using molarity, so I have 0.250 liters of solution. And then I know my molarity, really what it's saying is 0.10 moles of potassium hydroxide, KOH, for every 1 liter of solution. Then, once I have moles of KOH, then I can go ahead and find grams using the molar mass, which is 56.11 grams of KOH for every 1 mole of KOH. So that first step converts us to moles of KOH, and the second step converts us to grams of KOH. I get 1.40 grams of KOH. That's how many grams of KOH we would need to produce a 250 milliliter solution that has a concentration of 0.10 molar. The second question, again, is about ions. So magnesium nitrate, when we look at magnesium nitrate, it contains 1 magnesium ion for every 2 nitrate ions. So when that dissolves, it breaks apart into 1 part magnesium ion and then 2 parts nitrate ion. Again, I'm going to go through and use dimensional analysis. And since I have 2.5 grams of dissolved sodium or magnesium nitrate, I'm going to start with that. 2.5 grams of MgNO3, 2. And I'm going to convert that to moles of magnesium nitrate and then moles of nitrate. Then to find molarity, you just have to do moles per liter. So we know that 1 mole of magnesium nitrate, MgNO3, 2, has a mass of about 148.33 grams of MgNO3, 2. And I know according to my equation up top that for every 1 mole of magnesium nitrate that I dissolve, I end up with 2 moles of nitrate ions. That gives me 0.337 moles of nitrate, NO3 minus, oops, there we go. Now, knowing that molarity is moles of solute per liter of solution, I'm going to take my moles of nitrate, which is what I'm looking for, the concentration of, and I'm going to divide that by the volume, which up here is 100 milliliters. So that's going to be 0.100 liters. And, oh, you know what? I forgot a 0 there. My bad. There's a 0 there and there's a 0 there. Yeah, fix that. Sorry about that, everybody, because your final answer then ends up being 0.337 molar nitrate ion in that solution. That's our final answer.